Assalamu alaikum. We are going to begin with second differentials. In first differentials, we saw that by finding out the first differential, which is f dash x or dy by dx, we determined the gradient, and we know that dy by dx is equals to 0 at the stationary point. If the stationary point is the point of inflection or the turning point, for example, if this is the graph, or this is the graph, or this is the graph, or this is the graph, any kind of graph, whether it's a minimum point or maximum point, how do we determine that? We determine that by using second differential. How do we find out the second differential? For example, if there is a curve y is equals to 3x to the power minus 3 plus 2x to the power 4 plus 8x. So dy by dx is minus 9x to the power minus 4 plus 8x to the power 3 plus 8. Now for second differential, d square y upon dx square, we differentiate this statement of dy by dx. This becomes 36x to the power minus 5 plus 24x square, and differential of constant is 0. So what do we determine by finding the double differential or the second derivative? By finding the second derivative, we find out whether it's a minimum point or a maximum point. When second differential is greater than 0, it's minimum, and when it's less than 0, it's maximum. Now let's do a question. Given that y is equals to this, find the second differential. The way we write f dash x for first differential, we write f double dash x for second differential. But for that, we first need to find out the first differential or dy by dx. Let's make this statement usable first. Y is equals to 5 into 2x minus 3 to the power minus 3 because I take it in the numerator. I find out dy by dx first. This becomes minus 15 2x minus 3 to the power minus 4 and differential of the expression inside, which is 2. So dy by dx is equals to minus 30 2x minus 3 to the power minus 4. Now we find out the second differential. D square y upon dx square is equals to 120 2x minus 3 to the power minus 5 and differential of the expression inside, which is 2, that is 240 into 2x minus 3 to the power minus 5. This is the second differential. Next question. Curve has an equation this. Find the range of values of x for which dy by dx and second differential are negative. Negative means less than 0. So let's first find out dy by dx. dy by dx of the expression are 3x square plus 6x minus 9 and differential of the constant is 0. We write 3x square plus 6x minus 9 is less than 0 because negative. We divide the entire expression by 3. X square plus 2x minus 3 is less than 0. X plus 3, x minus 1 less than 0. X, if I do not consider this inequality, then from here x is equals to minus 3 and x is equals to 1. Since this is a quadratic curve, this is going to look something like this. Minus 3 and 1 plus 1. This is the place where the values are negative. So the range is minus 3 is less than, x is less than 1. For second differential, we differentiate this equation. So second differential is equals to 6x plus 6. I equated 6x plus 6 is less than 0 because negative. Divide the entire expression by 6, we get x plus 1 is less than 0. X is less than minus 1. This is the range. Now for part B, show that first differential square is not equal to second differential. First differential square will be 3x square plus 6x minus 9 square, which is definitely not equal to 6x plus 6. That's pretty evident. Next, curve has an equation this. Show that dy by dx is equals to 0 when x is equals to minus 2 and x is equals to 2 upon 3. First, let's find out dy by dx of this function, which is 3x square plus 4x minus 4. We equate it to 0 and factorize it. 3x square plus 4x minus 4. 0 is equals to 3x square plus 6x minus 2x minus 4. 0 is equals to 3x x plus 2 minus 2. X is equals to 2 upon 3 or x is equals to minus 2, hence proven. Part B, find the value of the second differential. So first we differentiate this expression, d square y upon dx square is equals to 6x plus 4. Find the value when x is equals to minus 2. When x is equals to minus 2, minus 12 plus 4 is equals to minus 8. When x is equals to 2 upon 3, then 6 multiplied by 2 upon 3 plus 4. This is 4 plus 4 is 8. That's the answer. Next question. Find the coordinates of the stationary point on the curve. Stationary points on the curve means dy by dx needs to be equated to 0. So first let's find out dy by dx is equals to 3x square minus 12. We equate it to 0 because stationary point. 3x square minus 12. Divide the entire equation by 3x square minus 4. Factorize it, x minus 2, x plus 2, which means x is equals to 2 or x is equals to minus 2. We need to determine the nature of these points, whether these are maximum or these are minimum. For that, we need to find out the second differential. So, d square y upon dx square is equals to 6x. When x is equals to minus 2, second differential is equals to minus 12, which is less than 0. It means this is maximum. When x is equals to 2, second differential is equals to 12, which is greater than 0, means minimum. When x is minus 2, that is the maximum point, and when x is 2, that is the minimum point. Next, the diagram shows part of the curve with equation this and the line OA where A is maximum point on the curve. X coordinate of A is A and the curve has minimum point at B0. A, B are constants. Find, show that B is equals to 3A. Now what do? We find dy by dx. dy by dx is equals to 3x square minus 4bx plus b square. As both of them are turning points, we equate it to 0. 3x square minus 4bx plus b square. Factorize it. 3x square minus 3bx minus bx plus b square is equals to 0. 0 is equals to 3x into x minus b, and this is minus b. 3x is equals to b, x is equals to b upon 3, or x is equals to b. This is the bigger one and this is the smaller one. So smaller a, because obviously b upon 3 is equals to 0.33b. So this is the smaller one. Smaller one is equals to a. So a is equals to b upon 3. 3a is equals to b, hence proven. Next we have application of second differential. For application of second differential, we will have questions involving area and volume. So surface area of a solid cuboid is this. Surface area is equals to 100. Volume is equals to side multiplied by side multiplied by side, which is x square h. Surface area is 2 into length multiplied by breadth plus length multiplied by height plus height multiplied by breadth. 100 upon 2 is equals to x square plus xh plus xh. 50 is equals to x square plus 2xh. 50 minus x square upon 2x is equals to h. Find h in terms of x means we had to find the expression for h which needed to have x in it. Part B, show that volume is equals to this. So volume is equals to x square h. Volume is equals to, we pick the value of h from here. X square into 50 minus x square upon 2x. This square and this x cancels. Now let's solve the bracket inside first. 50 upon 2 minus x square upon 2. Let's take the x inside. V is equals to 25x minus x cube upon 2, hence proven. Next, given that x can vary, find the stationary value of v and determine whether this stationary value is a minimum or maximum. Means we pick the expression for volume and we find out the first differential. dv by dx is equals to 25 minus 3x square upon 2. Let's find out, this is the stationary value, so 0 is equals to 25 minus 3x square upon 2. X square is equals to 25 multiplied by 2 upon 3. X is equals to plus minus under root 50 upon 3. Determine whether this value is maximum or minimum. Let's find out the second differential. Of which expression? This one is equals to minus 6x upon 2. This is minus 3x. So when this is negative, for negative, turning point is going to be a maximum value, and for positive it's going to be minimum value. For negative it means the value is less than 0, so maximum, and when it's greater than 0 then minimum. Since x is the side of this cuboid, it cannot be negative. So when we pick x positive under root 50 upon 3, this is going to be negative always because there's a negative sign. So when second differential is less than 0, it's maximum. The nature is maximum. Next, diagram shows a solid cylinder of radius r, height 2h, cut out from a solid sphere of radius 5. Volume of cylinder is C. Okay, express r in terms of h. For this we are going to use Pythagoras. So 25 minus r square is equals to h square. 25 minus h square under root is equals to r, because we wanted to express r in terms of h. Second, show that volume is equals to this. Volume of a cylinder is pi r square h. Since this is volume of the cylinder, height of the cylinder here is 2h. So volume is equals to pi r square is 25 minus h square, and height is 2h. So volume is going to be 50 pi h minus 2h cube, 2 pi h cube. Hence proven. Find the value of h for which the stationary value of start. Part C. Find the value for h for which there is a stationary value of v. Means we first differentiate dv by dh is equals to, this becomes 50 pi minus 6 pi h square. Since this is a stationary value, we equate it by 0 and divide the entire equation by 2. 2 pi. 25 minus 3h square. H is equals to 25 upon 3 under root, h is equals to 5 upon root 3. Only the positive value since this is the height. Determine the nature of stationary value. First we find out the second differential. Of which expression? This expression. This is going to be minus 12 pi h. This is always going to be negative because there's a negative sign over here. So this is going to be the maximum value. Next, diagram shows a hollow cone with the base radius 12 and height 24. Solid cylinder stands on the base of the cone and the upper edge touches the insides of the cone. Cylinder has a base radius r and volume v. Express h in terms of r. We are going to use the concept of similar triangles over here. This is one triangle. This is 12 and this is 24. And this is another triangle here. So this is r and this is 24 minus h. So r upon 12 is equals to 24 minus h upon 24. 2r is equals to 24 minus h. H is equals to 24 minus 2r. This is the expression that we are looking for. Part B. Show that volume of the cone cylinder is this. Volume is equals to pi r square h. Volume is equals to pi r square h. 24 minus 2r. Volume is equals to 24 pi r square minus 2 pi r cube. Proven. Next, Find the volume of the largest cylinder that can stand inside the cone. Largest cylinder means maximum. Volume dV by dr is equals to 48 pi r minus 6 pi r square. 0 is equals to, divide the entire thing by 6, pi, 8 r minus r square. 0 is equals to r into 8 minus r. Radius is equals to r. Find the volume of the largest cylinder. Volume is equals to 24 pi into r square, 8 square, minus 2 pi into 8 cube is equals to 512 pi. This is the volume of the largest cylinder that can stand inside the cone. To check whether that's the maximum point, we are going to find the second differential. So, second differential of this one, 48 pi minus 12 pi r. This, when we put 8 over here, 48 pi minus 96 pi, this is going to be negative. So, when this is negative, this is maximum. This point is maximum. Next we have chain rule or related rate of change. Whenever we are talking about rate of change, we are always talking about changes with respect to time. Always. Rate always means with respect to time. But now we are talking about chain rule. Chain rule means there will be two things connected with each other. For example, volume is equals to pi r square h, and one of them is going to be in terms of the other, means the entire equation will either be in h or either be in r. See, the entire equation is in r form. So, how do we write rate of change? Dy by dx is equals to dy by dt into dt by dx. The denominator of the first one and the last one needs to be the same. Numerator of the first and the second one needs to be the same, and denominator of the second one and numerator of the second one needs to be the same. But how do we get dt by dx? We don't. We will be given dy by dt. Sorry, we will be given dx by dt, means rate of change of x, and we reciprocate it. For example, if it's given 6 seconds, because rate of change with respect to time is going to be as a unit of time. So, dt by dx is going to be 1 upon 6. Let's start. Given that h is equals to t square upon 5, find the rate of change of h with respect to time when t is equals to 2. We have to find out dh by dt, rate of change of h. So, this is h in terms of t already, so dh by dt can be calculated by differentiating it. This is 2t upon 5. We put t is equals to 2 here, and this gives me 4 upon 5 is equals to dh by dt. But where is related rate of change here? In this question, we don't have related rate of change. We just wanted to explain what is rate of change. Next, variables v and t are connected by the equation this. Find the rate of change of v with respect to t when t is equals to 4. Here also, we can simply find out dv by dt, which is equals to 4t minus 3 when t is equals to 4. So, 16 minus 3 is equals to 13, which is rate of change of v. Next, a point with coordinates xy moves along the curve y is equals to something in such a way that the rate of increase of x, means dx by dt, has a constant value of 0.06. Find the rate of increase of y. Dy by dt is required. When x is equals to 3, state whether the y coordinate is increasing or decreasing. For increasing and decreasing function, we just need the first differential. If first differential is greater than 0, then this is an increasing function. First differential less than 0, decreasing function. So, let's start. Dx by dt is given and we have to find out dy by dt. So, chain rule, dy by dt is equals to dy by dx into dx by dt. Dy by dt has to be calculated. Dy by dx will be calculated from here. So, 1 plus 2 over 2 root 2x plus 3 under root. Why? Because 2x plus 3 power half, when you differentiate it, it becomes half into 2x plus 3 power minus half, because half minus 1 is minus half, multiplied by differential of the expression inside. So, dy by dt is equals to 1 plus 1 over under root 2x plus 3. Now, we see that x is given. So we plug in x into this expression. dy by dt is equals to 1 plus 1 upon under root 2 3s are 6 plus 3, which is under root 9, 1 plus 1 upon 3. So after taking LCM, this becomes 4 upon 3, which is greater than 0. Therefore, y is increasing. The y coordinate is increasing. Next, water is poured into the conical container at the rate of, water is poured means what is changing? Volume is changing. Here it's given cube. So dV by dH, sorry, dV by dt is equals to 2 pi. After t seconds, volume of the water of the container is given by V is equals to pi h cube upon 12. H is the height. Find the rate of change of h when h is equals to 5. dH by dt is equals to dH upon dV into dV upon dt. dV upon dt is given. dH upon dV is not given, and how do we find it out? This is V is equals to something, means we will find out dV by dH first. dV by dH is equals to 3 pi h square upon 12 is equals to pi h square upon 4. When we want to find out dH by dV, we will reciprocate it. So dH by dt is equals to 4 upon pi h square into 2 pi. Pi cancels. H is equals to 5 here. So we have dH by dt is equals to 8 upon 25. Part B. Given that the container has radius 10 centimeter and height 20. Okay, radius 10, height 20. Find the rate of change of h, dH by dt, when the container is half full. Okay, so volume is given by 1 upon 12 pi h cube. We multiply it by half. This gives me pi into 20 into 20 into 20 upon 12 times 2. So this is volume is equals to 200 into 5, which is 1000 pi by 3. This is volume that we are going to use. When volume is equals to pi by 3, 1000 pi by 3, then we have find the rate of change of h when the container is half full. Now for half full container, we have to find out the height. How do we find that out? Pi h cube upon 12. Pi cancels. This is 4. And cube root of 4000 is equals to height. This is the height for which we are going to find out the rate of change of 8. Cube root of 4000 is 15.87. H is equals to 15.87. dH by dt is equals to dH by dV into dV by dt. dH by dV is same. So dH by dt is equals to 4 upon pi into 15.87 square multiplied by 2 pi. So this is 8 divided by 15.87 square, which is 0.03317. That is the rate of change of h when this is half full. So first what did we do? We found out the volume, total volume, because the container is has 10 centimeter radius and 20 centimeter height. We found out the full volume and halved it. Then for rate of change, for the new height, we had to find out the new height when the container is half full. Using that new height, we used the chain rule for rate of change. Next question. A curve has an equation. This point is moving along the curve in such a way that at P, y coordinate is increasing 4 units per second. dy by dt is equals to 4. X coordinate is increasing. Whether it's written increasing or decreasing, this is dy by dt or dx by dt. increasing or decreasing means rate of change. So dx by dt is equals to 6. We have to find out the x coordinate. So we have dy by dx is equals to dy by dt into dt by dx. dy by dx is given, can be calculated, 2x minus 2 is equals to dy by dt is given 4 multiply by dx by dt is given, but we need dt by dx, so 1 upon 6. We have to find out x. So this is 2x is equals to 2 upon 3 plus 2. 2x is equals to 8 upon 3 divided 8 upon 3. X is equals to 4 upon 3. Answer. We just had to find out the x coordinate. Let's do another question. A curve is such that dy by dx is given and a is 1 minus 3 lies on the curve. A point is moving along the curve and at a, y coordinate of the point is increasing at 3 units per second. dy by dt is 3. dy by dx is given. Find the rate of change of x, find the rate of increase at a of the x coordinate, means we have to find out dx by dt. How do we find this out? Dx by dt is equals to dx by dy into dy by dt. Dx by dt is equals to dx by dy means we look at this dy by dx and we reciprocate it. 3x minus 2 cube upon 6 into dy by dt is 3. So this is dx by dt is equals to 3x minus 2 cube upon 2. X coordinate is given 1. So we plug in x is equals to 1 into this one. Dx by dt is equals to 3 multiplied by 1 is 3. 3 minus 2 is 1. 1 cube is 1. Dx by dt is half units per second. Next, the point 4, 7 lies on the curve y is equals to fx and it's given that f dash x means dy by dx is given. Point moves along the curve in such a way that x coordinate is increasing. Dx by dt is equals to 0.12. Find the rate of increase of y when x is equals to 4. We want to find out dy by dt. So dy by dt is equals to dy by dx into dx by dt. dy by dt is equals to dy by dx is given, which is 6 upon under root x, because minus half is under root x, minus 4 upon x to the power 3 under root. 3 upon 2 means x cube under root, multiplied by dx by dt is 0.12. X is given to us 4. dy by dt is equals to 6 upon under root 4 is 2 minus 4 upon 4 cube is 64. So this is 8. The entire thing multiplied by 0.12 is equals to, this is, I am letting it stay 6 upon 2. 6 upon 2 minus 1 upon 2 into 0.12. dy by dt is equals to 5 upon 2 multiplied by 0.12, which is 3 upon 10 or 0.3 units per second. Next question. A weather balloon in the shape of a sphere is being inflated. The volume of the balloon is increasing at the rate of 600. dv by dt is equals to 600 per second. The balloon was empty at the start. Find the radius of the balloon after 30 seconds. Okay, if the volume has become 600 after 1 second, 600 centimeter cube in 1 second, volume time. So if in 1 second it's 600, then in 30 seconds it's how much? That is 18,000. Volume is equals to 18,000 after 30 seconds. So if volume is equals to 18,000 is equals to 4 upon 3 pi r cube. 18,000 multiplied by 3 divided by 4 pi, third root, is equals to radius after 30 seconds. So radius after 30 seconds is going to be third root of 18,000 multiplied by 3 divided by 4 pi, 16.25. Find the rate of increase of radius after 30 seconds. This is the radius after 30 seconds. So dr by dt is equals to dr by dv into dv by dt. dv by dt is given. Volume is changing at the rate of 600 centimeter cube in 1 second. First we find out dv by dr. dv is 4 upon 3 pi r cube. You differentiate it, it becomes 4 pi r square. So dr by dt is equals to, this is dv by dr, but we need dr by dv, so we reciprocate it. 1 upon 4 pi, r is 16.25 square, dv by dt is 600. This is equals to 0.181. Next, volume of a large circular mound of iron ore of radius r is molded by the equation this. For r is greater than or equal to -2. Iron ore is added to the mound at a constant rate of 1.5, okay, meter cube, means volume, rate of change of volume, dv by dt is 1.5. Find the rate at which the radius of the mound is increasing. dr by dt is required when radius is 5.5. dr by dt is equals to dr by dv into dv by dt. First we find out dv by dr from here. So this is 9 upon 2 into r minus half square. dr by dt is equals to dr by dv, this is dv by dr, so we reciprocate it. This becomes 2 upon 9 r minus 0.5 square into dv by dt is given 1.5, r is given 5.5. So dr by dt is equals to 2 into 5.5 minus 0.5 is 5 is equals to 2 upon 9 into 5 square is 25 multiplied by 1.5, which is 3 upon 2, 1 upon 75. That's the answer. Next, find the volume of the mound at the instant when radius is increasing at 0.1 meters per second. dr by dt is 0.1. Find the volume, okay. dv by dt is equals to dv by dr into dr by dt. Rate of change of volume is 1.5. dr by dt is 0.1. 15 upon 1 is equals to dv by dt, which is 15. From the initial equation, dv by dr is equals to this, 9 upon 2 r minus 0.5 cube, no, square, is equals to 15. 10 upon 3 is equals to under root 10 upon 3 is equals to r minus 0.5. Under root 10 upon 3 is 1.825 plus 0.5 is 2.32. When radius is 2.32, this is volume. Volume is equals to 3 upon 2 r minus half cube minus 1. So volume is equals to 3 upon 2 2.32 minus half cube minus 1, 8.04. That is the answer, and that is it for differentiation. With that, we come to the end of differentiation, and you can practice differentiation on your own. I'm leaving a lot of unanswered questions here, and that is going to be there in the notes, so you can practice them yourself.